Our first topic of this afternoon, we're going to be talking about black dot. I've labeled it an emerging disease in PEI. We've had black dot here for a number of years, but I wouldn't say that it's normally risen to the height of importance for a lot of folks. But I know I get more questions about it all the time. And so I wanted to get, we had Julie coming here anyway. We thought we might get her to come back up and talk a little bit about black dot, what they're seeing out in North Dakota, talk about the disease a little bit, and what we can do to stay on top of it. So I'll turn it back over to you, Julie. Clicker's there, I think.
Okay. Wonderful. Thank you, Ryan. Thanks, everybody, for coming back and listening some more. As Ryan said, again, I'm Julie, if you weren't here this morning, from North Dakota State, and this is Ryan's fantastic title. I can't say whether or not black dot is emerging in PEI, but I know certainly we've had a much higher emphasis on black dot in the States in general. I worked on black dot first time probably about 25 years ago, and at that time, most researchers would say, "Meh, it's just a nuisance. We don't really see a problem from it." Most people in the industry. Last fall, I had a major grower call me and tell me that we need to enlist researchers. We're going to start a black dot initiative, a black dot working group, because we need more research on black dot. So that's kind of, and I'll go through some of the reasons why I think that might be. So black dot is caused by a fungus, Colototricum cacoides. I showed some pictures earlier, and I'll show some more. This is sort of similar in some ways to verticillium. It forms small, dark resting structures that survive in the soil. It's often, as I said, it's often been overlooked. It interacts with other pathogens, and the symptoms often appear later in the growing season. The symptoms can very much be confused with other diseases, and I have a bunch of pictures to show you that. And sometimes losses occur without really obvious symptoms, and sometimes, a lot of times, you don't necessarily get losses. It just kind of is around, like I said, kind of not just a nuisance in some instances. So with black dot, one of the unique things about it is we infect stems. Black dot will infect stems, below and above ground stems, roots, stolons. There's a tuber blemish phase, and there's a foliar phase. So pretty much everything except the flowers can become infected and display symptoms and signs of the black dot pathogen. So I showed a similar image this morning where we have early blight and brown spot and black dot. And probably without the aid of a hand lens, you're going to have a very difficult time discerning among these. And why I say there's in need of a hand lens, because black dot, those small mycosclerotia, those small, where we get the name black dot from, will be, sometimes you can see them inside those lesions, and you wouldn't see that in an early blight or a brown spot lesion. But, and a lot of times, of course, they're all happening in the same leaf sometimes. And so it's really difficult to kind of discern what's happening with the foliar phase. For instance, these two pictures. Right, one's black dot, one's early blight, very similar sorts of patterns of what's happening. You don't necessarily see the concentric rings with black dot, and in some of these, you certainly can see where you maybe have that black dot in some lesions, but not all and not consistently. On the stems, it's a little bit different. It's a little bit easier to see. On your left-hand side, those are some earlier infections. On the right-hand side, that's what you see in stems later in the season. And again, that kind of graying area, in some instances, you can more easily discern those small black dots on the tissue. And sometimes it just looks like a gray or a black patch. And really here, in that circle, a lot of times where we see infection occurring in the above ground stem is where that petiole has fallen off. That leaf has senesced, the petiole falls off, you have a natural wound, and you have invasion of the pathogen from the soil into that wound, and a lot of times that's where it starts. And really in both of those stems, you can see where it's starting from that lower petiole. One of the things that black dot is commonly confused with, or actually acts in concert with, is verticillium wilt. So black dot is part of the early die complex. Along with verticillium wilt, along with nematodes, etc., black dot joins in on that party a lot of times. What we see if we typically have a characteristic verticillium wilt plant, the plants die upright, right? The leaves start to senesce and flag and wilt, etc., but the stem tends to kind of stay erect. With black dot, that stem will be laying over the hill, and then again, on that right-hand side, you can see those black fungal structures, and here they're very, very thick, and really that whole stem is just basically black. Sometimes, however, you might have a combination of the two, where you might even have in the same plant one stem that's laying over with black dot lesions and one stem that's standing up looking like typical verticillium wilt. So again, complicated, all acting in concert. So as I mentioned, we have that infection of above ground, below ground, the early die, working in concert with the early die on the stems and the roots and the leaf spot. We also have a tuber blemish phase, and we'll kind of look at that at the second half of the presentation here. Those foliar and stem lesions typically occur through wounds, and one of the things, like I said, with that petiole falling off, that's one way. But we also have a situation where if you're in sandy soils, when the sand blows, before row closure, when you still have an open canopy, the sand blows, the sand creates a wound. It also carries the wind carries those mycosclerotia, they get deposited, and you have black dots starting from those sand-blown wounds. And so we know that disease pressure is greatest in situations where we have high pathogen soil levels. So similar to verticillium wilt, where you may have reports of the verticillium propagules per gram of soil, at least in our area. Our growers commonly will take those data and determine management practices from there. It's a similar situation with colototricum, where you have higher levels of the pathogen in the soil, you have higher disease. That, of course, comes from many potato crops, and the pathogen just being multiplied on those potato crops every year. And as the tissue goes back into the ground, so does the pathogen. And then shorter rotations, you don't recover as quickly. Certainly, those fungal structures are very long-lived, but they don't survive forever. Like over time, you start losing them. And so if you have longer rotations, you lose them in between. And certainly, again, as I talked about with early blight and brown spot this morning, anytime you have a stressed crop, you're going to have increased problems with black dot. So here are some close-up images. The stem broken open, and you see all of those black dots. You have an up-close view of those fungal structures in the lower left-hand corner. On the right-hand side, I think this picture, you can really see those individual black dots, and you can also see this, what we call, has been termed an amethyst color. I don't know why it's amethyst and not pink. I didn't make that decision, but there you go. We call it amethyst. And you see that oftentimes on the roots, stolons, stems, sometimes on the tuber, right where the stolon attaches. The other thing that you will see, in addition to the sclerotia and the amethyst color, is that cortex, that outer cortex of the stem can be just easily rubbed off with your fingers, and it will just kind of decay away. And that's also very characteristic of black dot. So these are, I said, I've started working on black dot many, many years ago, and this was part of my PhD dissertation. And we looked at 2 fields each of 2 years, and we quantified the amount of pathogen in the soil, and we quantified the amount of pathogen in the plant tissue as the season went on, and also took visual foliar ratings. And so there's kind of a lot going on here to summarize, but the lines correspond to the amount of pathogen in the plant, And then the bars at the end are the visual stem incidence data. And as you can see, as we have more propagules in the soil, where we have 69 propagules per gram in the soil with the yellow bar, and 1 propagule per gram with the gold bar, and then our visual, our decreases in our visual in the bars, the blue versus the gold bar at the end. So it all kind of comes together. So there are 3 things that happened here, well, several things that happened here. One, we have more propagules per gram in the 2003 season with the gold bar, or the gold line. We also had a major rain event right around that 2 weeks after emergence. And that stressed the crop. It was a very sandy field, so we had leaching of the nitrogen. It's hard to catch up after that point, and so we had a plant stress. One other thing is, look at how early we can find it in the plant. We can basically find it at emergence. There's already infections that have occurred. And so what happens from that point forward later in the growing season, where in the end here, you basically ended up with, 100% of the plants having the pathogen in them. It just happened at a slower rate in 2004 as it did to 2003. So what happened there? So this middle space is kind of like what we're looking at, the difference of what's happening here. So these 2 graphs are those same data, right? 2003 in the gold on the left-hand side, 2004 in the green on the right-hand side. And in 2003, we have a direct relationship between total yield and the amount of pathogen in that stem. And these are taken at the same dates, around the 3rd week of August. So we have a distinct correlation with the amount of pathogen in the stem and the yield loss, which more pathogen in the stem, less yield. In 2004, when we didn't have the stressor and we didn't have as many propagules in the soil, we have a little bit of a trend downward, but we don't have that significant correlation and that significant relationship. So this really goes back to that idea that where a lot of researchers and a lot of growers were thinking, it's kind of a nuisance, that's really that right-hand side picture. But you certainly can have the situation on the left-hand side, given the right opportunities, the right environment. Okay, so we have some options for black dot foliar management. I alluded to that a little bit this morning, where we recommend for our growers to put on a QOI early in the growing season before row closure, so that you can get some coverage on those stems, so that when you get that blowing sand, you don't necessarily get that infection, right? We also, some research has shown that Quadris in furrow is also a good option, if that's available. And then certainly our group 7s can be effective. And again, either those of these that are labeled in furrow or early on in the growing season. Same situation with the group 3s. What I would caution is I tend to push that QOI, that group 11, early in the growing season, because you really want to save those 7s and 3s. They're more efficacious on the leaf spotting pathogens, the Alternaria complex. And so, the group 11s are not, the QOIs are not. And so really that's kind of how it pieces out. If I'm making the recommendation, I would say save those other groups for your early blight a little bit later in the season. We have seen that Minuet, Serenade soil, also applied in furrow will offer some benefit, and as with a lot of biologicals, that varies, but we certainly have seen a trend. And that's really the only one we've looked at really very closely. I can't really speak to the rest. Okay, so the second half to this story is the tuber blemish. And the tuber blemish is really what has kind of gotten growers really active in this idea that black dot is becoming more important. These are a couple of pictures. Again, you get kind of a gray to brown to silver discoloration on the tuber. It can either occur on the left-hand side here. You can have it occur kind of in spots. On the right-hand side, that appears as though it came from the stolon and infected through the stolon end and is infecting through the tuber. If you have a hand lens, you can see those small black fungal structures on the tuber surface, and that is a good distinction. This is what you can get in a processed product, either French fries or chips or what have you. You get some vascular discoloration from, similar to what you would see with verticillium. I mean, a lot of things cause vascular discoloration, right? Not just pathogens, but one of those that contributes to this is black dot. This is an image of black dot and silver scurf. Extremely difficult to tell the difference. And depending on the skin color, red, yellow, purples, I find almost impossible because you can't find the little black fungal structure on the purples, right? It all blends together. And so a lot of times I think what we have been used to silver scurf, I wonder how much of it's black dot. And that's certainly one of the things that has kind of made our growers more aware, is that when they send their tubers, their product off to get tested, they come, the results come back and maybe it's black dot and not silver scurf, or they're told it's both. And so this is really, I think, raised awareness about how much black dot is really out there. You can have black dot and silver scurf on the same tuber, and you can see those images here. Silver scurf tends to be a little bit more patchy and spotty versus black dot that generally kind of tends to be larger lesions, although there's a lot of overlap. When we look at that close up, again, maybe with your hand lens, you can see the silver scurf pathogen kind of has those spiky, to me it looks like when you get stitches and the stitches stick out, kind of. It's kind of weird, but that's what it looks like to me. And the black dot, again, you get those small, very distinct fungal structures. They typically don't have any other kind of black coming out of them. So where do tuber infections come from? They come from seed, they come from the soil. So this work was done in the UK a few years ago, and basically what they did here is they have 4 sites that they looked at, and the varying colors of bars, and they took tubers, mother tubers, seed tubers, with no symptoms, 5%, 5 to 20, greater than 20% symptoms, and planted them to see how much of a difference the seed inoculum was going to make. And on these first 2 bars, if you compare, so you're comparing all the black bars and all the dashed bars and all the white bars together, these first 2, like maybe there's a little bit of increase at that one site, but not necessarily a huge increase. And the same thing with the other 2 sites, is that you're not necessarily seeing a huge increase with the amount of black dot on the seed tuber. Now, what black dot on the seed tuber will do is, if you have a field where you don't have any of the black dot pathogen in the soil, the infected seed, of course, will introduce the black dot pathogen. But once you have that black dot pathogen in your soil, the infected seed tubers really aren't going to add much. This is one study, but there have been several studies that have shown the same thing, that infected seed really doesn't add much to the equation once the pathogen is established in a field. These graphs are looking at the amount of black dot in the tuber periderm. So they peeled the tuber and quantified the amount of pathogen in them and compared that to, on the left-hand side, the number of crops, and on the right-hand side, the number of years out of potato. So on the left-hand side, the number of potato crops, certainly when you have had 0 potato crops, you have 0 black dot disease on your tubers. But as the number of potato crops increases, that amount of black dot on your tubers rapidly increases and goes up very quickly, and really starts to kind of go up exponentially. On the right-hand side, we have the kind of the opposite thing, right? Where you've had a field that has had a lot of potato crops, and you take the time, how many years out of potato you're going to go, that also decreases over time. But you can see still at 15 years out, you're not at 0. You still have a little bit. Sure, you are very much substantially decreased it, but when you go back to that field, you're going to go back to the left-hand side, and you're going to start increasing it again. And that's just how this pathogen works. The other part of it is, the growers ask us, okay, so how do we minimize the amount of tuber blemish coming out of the field? And this is a little bit trickier question because, as I indicated, we've only just recently had an impetus from our growers in the U.S. saying the black dot tuber blemish is really starting to become a problem. Before, we had focused all of our efforts on the stem phase and reducing the yield drag from the stem phase. Now we're just really starting to take another look at the tuber blemish phase and what's happening. They've done a fair amount of work in the UK on the tuber blemish phase. They've been dealing with it for a lot longer than we have. They have different varieties, and so we're really kind of starting over a little bit on some of this. But some of what we do know is that the days that the crop is in the soil, as the days increase, the amount of black dot in those on those tubers increases. And that's basically that line that we're showing there. So, unfortunately, there aren't a lot of real great options with the tuber blemish phase at this point. So we know that seed treatment fungicides do not affect black dot. If you're applying a seed treatment fungicide and you're getting less tuber blemish, you're managing silver scurf. And that's great. We need to manage silver scurf too. If you're applying a seed treatment and you're not getting an effect, it's a possibility to look into the idea that it's not silver scurf, that it's black dot, because the seed treatments won't manage black dot. Those fungicides in furrow or before row closure, our data would indicate that, unfortunately, we can reduce the stem phase, but we have not been able to reduce the tuber phase with those applications. It just doesn't, it doesn't carry over. The crop rotation, avoid those fields with on short rotations or long potato history like we talked about in those graphs. And there is a soil test available. It is out there that certainly you can test your soil. Reduce plant stress, we talked about that. We know that those plant infections occur very early in the season. Limiting that time, the duration that the tubers are in the soil, harvesting as soon as you can. Obviously, you have a million reasons when to harvest. I get that. But just add this on top of your decision-making tools. And that idea that the black dot pathogen is seed and soil-borne, but certainly we know that once you have it in your field, the soil-borne phase is more important. That's it. I'll take questions. I think,
Questions for Julie?
if I have time.
Yeah, we got a few minutes. If you are planning to go to the other room, you can feel free to go. But if anybody has any questions for Julie on black dot?
Yeah.
Can you maybe use the microwave there, or microphone?
Or the microwave.
Yeah, whatever.
It works.
It's the afternoon.
Yeah.
Like brown mustards as the
Yeah.
soil fumigants, whether there has been any work to see whether they're effective against like black dot or the alternary organisms.
Yeah, so
I mean, there's been some work with verticillium to look at that. But,
yeah. So one of the things that we know with black dot, I can't put my finger on any research on mustards for black dot control. One of the things we know that is with like metam sodium does not affect, like it will do a pretty good job on verticillium wilt, but it does not affect Colototricum. So there are some differences certainly in soil fumigants, and so I think you'd have to look at those specific, I think it'd be interesting to see, certainly one of the areas that needs to be investigated, but as far as I know, it's not been an effective, yeah. All right, thank you.
One more
Oh,
there.
I got a
sorry,
question
sorry.
here. Can you tell us more about the measuring to see what you have in the soil, like the inoculum that's there? Like, how do
Yeah.
you do that? And is that something we can do here, maybe?
So it's something that we do in our lab, and we have some commercial labs in the United States that do it, a couple, and it's just kind of getting started. I have no idea of the availability of that here. I would say that it is a pretty straightforward PCR kind of measure that if somebody is interested, we can at least maybe talk about going in the right direction as far as getting somebody set up or what have you, if there's interest.
We don't currently do it in PEI, but if there was demand for it, we could probably talk with PQI and like they would have the equipment to do it. We just need to get the primers and
Yeah.
get things ready.
Yep, yep.
Any other questions? No? Thank you very much, Julie.
Thank you.
Really appreciate it.
Thank you.